Hello, my name is John Gabriel, and this is the New Calculus channel. Today, I'm going to speak about the mean value theorem and how it's been misunderstood since the time of Newton. Well, he actually didn't know about it, but all the academics that have been learning about the mean value theorem and teaching it have never actually understood it. And the very fact that they state it unremarkably is proof. And I'm going to show you now why the mainstream statement of the mean value theorem is completely unremarkable and doesn't actually reveal what the mean value theorem is all about and how to prove it constructively. So let's begin. Now, when I was a young child, well, I wasn't that young. I was about 9 or 10 years old. I used to open up a page in the Britannica at the library. That was the only set of encyclopedias that were available. And I had no choice but to read those. So I would start on a given page and then carry on reading for hours on end, and I'd skip from one topic to another. But what interested me most was mathematics. And the first time I read about the mean value theorem, this is what I remember. This entry in the Britannica, as you see, the entry up here, it says mean value theorem. Of course it's wrong, but I will show you now what it says and then show you that it's completely unremarkable, this statement. And of course, this particular unremarkable statement is not wrong itself, but this paragraph here is wrong. Okay, so I'm going to read the wrong paragraph out to you, and then I'll tell you why it's wrong. So it says that well, first of all, the unremarkable statement is that the slope of a line connecting any 2 points on a smooth curve is the same as the slope of some line tangent to the curve at a point between the 2 points. And in fact, there could be more than one such tangent line depending on the function. So it's normally stated like this: f prime of c is equal to f of b minus f of a divided by the interval width. Okay, and the paragraph that caught my eye when I was very young was this paragraph here. It says, although the mean value theorem seemed obvious geometrically, proving the result without appeal to diagrams involved a deep examination of the properties of real numbers and continuous functions. Other mean value theorems can be obtained from this basic one by letting f(x) be some special function. That's just complete and absolute hogwash. Okay, so first of all, there is no such thing as a real number. And by the way, continuous functions are not sufficient for the mean value theorem. You need to have a smooth function. Okay, smooth means that it is possible to construct a tangent line at every point in a given interval of the curve or function. So in any case, it took me quite some time after that to reach these conclusions. At first I was awestruck because it said a deep examination. And of course, you know, at that time I hadn't yet studied all the theory of real numbers. The bullshit of Dedekind cuts and equivalence classes of Cauchy sequences and the like. But at any rate, I'd say about 10 to 15 years later, I actually discovered the real meaning of the MVT. And by the way, the MVT is not just another theorem in mathematical analysis dealing with a type of average. It doesn't deal with a type of average. It deals with an arithmetic mean. Nothing else. The mean value theorem is about an arithmetic mean, and it has nothing to do with any other average, okay? And it's not just useful for establishing other theorems, such as the fundamental theorem of calculus, which is derived directly from it in one step, but it is the reason all of calculus works. Stop the video and just pause a little bit on those words that I just told you right now. The mean value theorem is the reason calculus works. There is no other reason, okay? And the mean value theorem should be called the fundamental theorem, by the way. And of course, the morons who came before me, who didn't know shit about mathematics, wrote a lot of different textbooks. Fools like Professor Gilbert Strang from MIT and his ilk set up, this idea that the fundamental theorem can be broken into two parts and that there's a mean value theorem for integrals and an average value theorem. That's all bullshit, okay? Everything that is realized, everything that is realized from the mean value theorem, and those particular theorems that they're talking about are just different variations of the same mean value theorem. Okay, so now the first time when I tried to prove this constructively, I had great problems because mainstream calculus is so broken. I mean, the machinery is so flawed and so broken that it's hard to do anything with it as it stands, okay? So in order to prove that this here that you see in front of you, the statement, is an arithmetic mean, I had to actually understand and discover many other things that were not stated in the mainstream. And this article here, which I shall provide a link to, and by the way, I've created other videos like this, but I'm stating it in a different way this time, and and hopefully you'll be able to understand it. So what I'll do is I'll provide a link to this, and you'll be able to see what my reasoning here was. You don't even deal with real numbers in the mean value theorem. You deal with magnitudes, okay? And I'll show you how you can, using a positional derivative, which is this statement here that you see in this line here, using a positional derivative, you can actually prove the mean value theorem constructively, okay? So now, in the new calculus, by the way, none of this is needed. You don't use infinity, and you don't use limits, and you don't need any of this nonsense. But I had to do it using the flawed machinery. And in this document here, which is called the mean value theorem explained, I show you how to do it, okay? And what really happens is that this sum telescopes to give you this arithmetic mean that you see here and that you're so used to seeing, this f of x plus w minus f of x over w, which is the same as f of b minus f of a divided by b minus a. So, and of course, this f prime of c is really given by the expression that you see on the right, and it's very well defined as the product of two arithmetic means. Okay, now I was the first human to discover this knowledge. No one before me in human history ever knew these things. Okay, so, but still, this isn't the new calculus. And I actually discovered the new calculus, which doesn't use any ill-formed limits. Now, there's also an article about the positional derivative, which is actually a theoretical construct, but I prove in this article that it works, okay? And so I would advise you to read this article first before you read the mean value theorem explained. So read this article on the positional derivative, and then the article on the mean value theorem. And now all this here is theory that I created to try to patch the flawed mainstream calculus, okay? But it's so broken beyond repair, ultimately, that I eventually realized the geometric new calculus. The new calculus is based entirely on geometry. You don't need any of this nonsense, and you can do everything with the new calculus and much, much more. So don't listen to the libelers and the haters and the morons who get on this channel and tell you you can't. You can. Okay, so I will also place a link to my free ebook in the details section. And I encourage you to click like on my video, because I have many enemies and they will try to destroy everything I have discovered. And also to spread the news. And if you're not already a subscriber, become a subscriber. And so anyway, I hope that you've enjoyed this little video. It's not easy for me to produce videos anymore because I have lung issues and it's hard to talk. So I'm sharing that private knowledge with you, but I'll keep on trying. So anyway, this is a new calculus channel, and my name is John Gabriel. Till next time, goodbye.